Adding and subtracting polynomials. Before we get there, you're at a neighborhood cookout. It's summer. The sun is out. It's hot. The really large bearded man with a trucker hat and sunglasses is cooking the hot dogs and hamburgers. You go through the line with all the old people. There's the chips. There's the slaw. There's the potato salad. You get to the end of the line, and at this moment, you can see the following canned drink options at the end of the table with the napkins and the forks. You got that picture? All right, so there's all the Cokes, there's all the Sprites. If you wanted to write an expression that represented how many and what kind of canned drinks we had, how would you do that? Well, let's count up how many Cokes we got, okay? How many Cokes we got over there? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we got like 12 Cokes. And how many Sprites we got? 1, 2, 3, 4, 5, 6, 7, 8. So we could write it like 12 Cokes plus 8 Sprites. Yeah, that's pretty straightforward. That's what we got at the end of the table. That's all the canned drinks. In total, we'd have 12 Cokes and 8 Sprites. I want to shorten that. I want to write it like this. Let's say 12C plus 8S, just to be a little bit lazy. Okay, 12 Cokes, 8 Sprites. That's how we'd write that. Next one, same kind of thought process here. You know, if we wanted to write an expression for this, I'd have Cokes, 1, 2, 3, 4, 5, 6, 7, 8, 9 Cokes. Plus how many Sprites? 1, 2, 3, 4, 5, 6, 7 Sprites. Could write something like that. All right, something different here. Coke Zero. Just the Coke. That is not the same as a Coke. It wants to be Coke. They're trying to make it the same thing as Coke, but it is not the same thing as Coke. So let's get all the normal regular Cokes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Cokes, right? So I'm going to call that 10C. And then all the Sprites. 1, 2, 3, 4, 5, 6, 7, 8 Sprites. Plus, then we got this 1, 2, 3, 4 Coke Zeros. I'm going to put a Z right there. So that could be an expression that would represent all the canned beverages there. You know, Coke Zero was pretty bad, but here we go. Look at this. Ugh, that one at the end there. All right, Cokes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Cokes. Plus, how many Sprites? 1, 2, 3, 4, 5, 6, 7, 8 Sprites. Plus, how many Coke Zeros? 1, 2, 3, 4 Coke Zeros. I'm going to make that Z. And then we got, plus there's 1 Pepsi. Okay. Next. Well, you know, I didn't even need to put that number right there. You would know how many Cokes are in that little box without even that number being right there. How many are in there? 12. So it's kind of like I've got 12 Cokes plus another 12 Cokes plus 1, 2, 3 Cokes plus how many Sprites? 1, 2, 3, 4 Sprites plus 1 Coke Zero. And, you know, if I want to write, just kind of simplify some of these, well, how many total Cokes do I have? Well, I got 12 right here, plus 12 would be 24. So 12 plus 12 would be 24, plus 1, 2, 3 more. That would be 27 Cokes plus 4 Sprites plus 1 Coke Zero. At least it's not Pepsi. Okay? Now, this doesn't say Cokes and Sprites and Coke Zeros and Pepsis and Diet Cokes and all that kind of stuff, but same thought process here. I got 1x, 2x, 3x, 4x. 4x plus how many y's? 1, 2, 3 y's. Okay, those are like when all the Cokes are all spread out over the table. Right here, I've got 6-pack of Coke plus another 1-pack. 1. That would be 9 Cokes or 9x plus 12 pack of Sprite plus 1 plus 1. That would be 14 Sprites there. All right, so what's weird about this last one? Well, there's some minus signs here. It's almost like someone drank some of the Cokes or something. So I had 8 x's plus another x. That would be 9 x's. Minus 2 would be 7 x's. How many y's? Well, I got 6 and 1 y minus 3y. I think that would be 6 plus 1 is 7. Minus 3 is 4y. Okay with that? Same kind of stuff right here. I'm not going to do all these, but we'll just kind of jump through some of these. On the top right, those are some different letters. That's okay. I just go through and I underline. Those are the A's. There's an A. That's it for the A. So 3A plus 6A would be 9A, negative 9B minus 10B. So if somebody drank 9 Sprites and then somebody drank 10 more Sprites, how many Sprites got drunk, drinked? Punch in a calculator if you need to. Negative 9 minus 10, that would be negative 19 Sprites. And then plus 11 minus 7, 11 minus 7 would be plus 4, just like that. Down on the bottom down here, I've got M, so 2M minus 1M plus 7M. So I got 2M, there's a 1 hiding right there. So 2 minus 1 is 1. Plus 7 is 8M. And then I've got 3 and 2, that would be plus 5, and then the only thing left is that minus 8x. Now, it doesn't matter which order these go in as long as they have the same sign out front. Like if you decided you wanted to write it negative 8x plus 8m plus 5, either one of those is correct. That one's right and that one's right as long as those signs out front are the same. These are different. Why are these different? They have parentheses around them. Okay, if there is a plus sign right there with the parentheses, you can forget that the parentheses are even there. You're taking, this is almost like a cooler full of Cokes and Sprites, and you're going to add it to this little cooler of Cokes and Sprites over here and kind of see what all goes together. So I'm going to have 9x squared minus 7x plus 5 plus 6x minus 5. And then I'm going to underline my like terms just like I just did. So 9x squared, what goes with it? Well, there's not another x squared term. There are some x's, but there's not an x squared term up there. That's kind of like saying Coke Zero and Coke are the same thing. They're kind of close looking, but they're not the same thing. Negative 7x plus 6x. Negative 7 plus 6 would be negative 1x. 5 minus 5 is 0. This is a final correct answer. You could also write it like without the 1 there. So 9x squared minus 1x like that. Both of those are fine. This one makes you look smarter. First one is correct. Second one makes you look smarter. On the top right, there's a minus sign in front of a set of parentheses. And when I have a minus sign in front of that set of parentheses, I like to say we're going to distribute that to each one of those terms right there. And when I distribute that, I need to change the signs of everything in that second set of parentheses. So I'll have negative 3x squared plus 14x. So now I'm going to start changing the signs. If they're positive, I'm going to make them negative. And if they're negative, I'm going to make them positive. Change them. So this is minus 8x squared plus 2x minus 4. Now it's just like what we just had. Let's do a negative 3x squared and negative 8x squared. That would give me negative 11x squared plus 14x plus 2x. That would be 16x minus 4, just like that. Let's try the one on the bottom right down here. I've got to distribute right there to all three of those. That means I'm going to be changing the signs. That's going to be negative 4x squared. That's going to be negative x, and that's going to be positive 2. Change the signs of everything inside those parentheses. Combine like terms. 5x squared minus 4x squared. That would just be 1x squared. minus 10x minus 1x would be minus 11x. That's the only constant right there. Let's call it plus 2. Now, this is completely correct, sufficient answer. More than likely, you would see something like this if it was like a multiple choice question on a test or something. They would leave that 1 off the front. It means exactly the same thing, though. It looks prettier. Makes you look smarter. Find the perimeter of the following polygon. Perimeter! What's perimeter mean? That means add up all the sides. So I would have the perimeter would be 2x minus 1 plus 4x plus 3 plus negative x minus 8. Added up all the sides. Now I've got a plus sign and a bunch of parentheses there. I know that I can drop those parentheses if I have the plus sign. So plus 4x plus 3 plus negative x minus 8. Some people get upset about that double sign right there, that plus negative x. I don't worry too much about that. That would be 2x plus 4x would be 6x, minus 1x would be 5x, and then negative 1 plus 3 minus 8 would be, what, negative 6? Your perimeter is 5x minus 6. Next one, this is an equilateral triangle. All three sides are the same. How do I know that? They got those little dashes on them. So if it labels that one as 3x minus 5, that means that this one is 3x minus 5, and that means that one is 3x minus 5. The perimeter would be 3x minus 5 plus 3x minus 5 plus 3x minus 5. You could drop the parentheses because there are plus signs right there. And then combine your like terms. 3x plus 3x plus 3x would be 9x. Negative 5 minus 5 minus 5 would be negative 15, just like that. Last one right here, I've got a rectangle, and I got to find the perimeter again. So I got to add up all the sides. This one has 1 dash on it. This one has 1 dash on it. That means they are the same. This one has 2 dashes on it. This one has 2 dashes on it. That means that they are the same. So I'm going to have perimeter equals x minus 5 plus 3x plus 7 plus x minus 5 plus 3x plus 7. I got plus signs in between all those so I can rewrite it without the parentheses. And then I'm going to combine my like terms. X plus 3x plus x plus 3x, that would be 8x. And then negative 5 plus 7, negative 5 plus 7 would be plus 4. Your perimeter for that rectangle is 8x plus 4.